everybody. Today we're covering polynomial functions and their graphs. Our objective is to identify and describe the important features of the graph of a polynomial function. Now the question is asked, how many terms can a polynomial function have? Well, you'll have some polynomial which probably would look something like this, x to some exponent plus 3x minus 4, something like this. Now, whatever the polynomial exponent is here, the number of terms the polynomial will have will be the exponent minus 1. So, if this exponent was a 2 for, say, x squared, the number of terms that the polynomial will have, the maximum will be 1. If this is x to the third, it will be 3 minus 1, or 2. X to the fourth, 4 minus 1, or 3 terms. X to the fifth, 5 minus 1, or 4 terms, and so on and so forth. So the number of terms a polynomial can have, the maximum number of terms, is whatever the exponent is minus 1. Okay, now let's move on to exercise 1, where it says use your calculator to sketch a graph of the polynomial function and find any local maxima or minima. So we want to sketch y equals x cubed plus 3x squared minus x minus 3. So let's bring up our calculator, and we want to sketch x cubed plus 3x squared minus x minus 3. Alright, let's graph that. Okay, so here's the graph. Now, we notice here this is x cubed, which is 3 for our exponent. And how many terms does this particular polynomial have? 3 minus 1, which is 2. Here's our first term, and here's our second term. 2 terms. 3 minus 1, 2 terms. Now, we want to find our local maximum and minimum. This is really simple on a TI-84 calculator. We can simply hit the second key, trace, and then for maximum. Then we will maneuver to our left bound here. We'll hit enter, move over just a tad bit to our right bound, hit enter. Guess I'll move a little bit more, I'll hit enter, and it looks like it's saying that our maximum point is at negative 2.15 and 3.08 if I round it. So our maximum point is at negative 2.15, comma 3.08. Okay, so that's our maximum point. Now, let's see, negative 2.15 roughly here, 3.08 roughly about here. So I'm just plotting my maximum point on the graph. Now let's find our minimum point. Second, trace, option 3, minimum. I'm going to move my cursor to find my left bound here, enter, move over a little bit to find my right bound, and guess. And it's saying that our minimum point is at 0.15 for the x and negative 3.08 for the y, roughly if I round it. So my minimum point is 0.15, comma, negative 3.08. So that is my minimum point. If I plot that, 0.15 is just past the 0, 3.08 about right there. So that's my minimum point. Now, it says to also sketch the polynomial function. What I'm also going to do is I'm going to find the zeros here, and I'm going to plot the zeros on my graph and then sketch it. And we have 1, 2, 3 zeros. So we'll find my first zero. Second, trace, option 2, 0. Scroll over. My left bound, enter. My right bound, enter. Guess. -3. So if I go to -3, that's one of my zeros. Let's find my second zero. Second, trace, 0. Scroll back around this way. That's my left bound, enter. The more, that's my right bound, enter. Guess, -1. -1 is another zero. And looking at my graph, it looks like +1 is the other zero, but just to make sure, second, trace, 0. Scroll over, my left bound, enter, my right bound, enter, guess, and yes, +1 is my other zero, +1. So what I've done now is I've plotted my maximum point, my minimum point, and my zeros, and now all I'm going to do is just follow the trail of those plots in order to sketch a polynomial function. Okay, so after I do that, so I've sketched it, and there is my polynomial function sketched with my local max and minimum there. Okay, let's proceed on. Now, exercise 2, name the intervals over which the function is increasing or decreasing. Whenever we're naming the intervals, we always want to go on our x-axis. Here, with this particular graph, we see that right here at 1, when x is 1, this is when this particular function is increasing, and it continues to increase. So it's increasing from 1, and it doesn't stop increasing, so it's going all the way to +infinity. Okay, I'm going to put a bracket around the 1 because that's where it starts. Infinity you cannot contain, so you would place a parentheses. Now, the decreasing interval. This particular function is decreasing all the way from -infinity until it gets to +1. So it's decreasing from -infinity to +1. Again, you can't contain infinity, so that has parentheses. 1 is where this particular function stops, decreasing to 1. So there are our increasing and decreasing intervals.